All right, so we're gonna be doing some Q equals MC delta T practice problems. So these are the QMCT practice problems from page 38 in your Unit 2 packet. So let's look at question 1. Question 1 says, calculate the amount of heat needed to increase the temperature of 250 grams of water from 20 degrees Celsius to 40 degrees Celsius. All right, the very first thing we should do is write down our terms and figure out what we are given and what we need to solve for. So in that first question, we can see we are given 250 grams as our mass, and we are told our temperature increases from 20 degrees to 40 degrees, or 46 degrees, excuse me. So that means that 46 degrees would be our final and 20 would be our initial, and it's in Celsius. And our question did let us know we are working with water. So on our reference table B, we know our specific heat capacity of water is 4.18. And the question says calculate the amount of heat. So we're finding our Q. I always write the formula Q equals MC delta T. It is on your reference table T, so you don't need to memorize it. Now we can plug in Q equals 250 grams times our heat capacity of water. And finally, we're going to multiply it by our difference in our temperature, which when you do 46 minus 20, you should get 26. And I'm going to make it Kelvin. So remember, change in temperature is the same for Celsius and Kelvin on both scales. All right, now we can go ahead and solve. When we do this, we get 27,170. And for these problems, we do not have to put correct number of significant figures because the question does not ask us. Only do correct sig figs if the question asks you. So in this case, I would leave it at 27,170. Our unit is joules. All right, question number 2. Question number 2 says, calculate the specific heat capacity of copper, given that 204.75 joules of energy raises the temperature of 15 grams of copper from 25 degrees Celsius to 60 degrees Celsius. Once again, we're gonna write down our terms and figure out what we're given and what we need to find. So for this one, we are told calculate specific heat. So we're gonna find the C. We're told our Q value is 204.75 joules. And we are also told that we have a mass of 15 grams and that our temperature goes from 25 to 60. So 60 would be your final, 25 would be your initial. All right, once again, we're gonna write our formula. Q equals MC delta T. For those of you who like to just plug in and then solve, go for it. I'm gonna rearrange my formula. So I need to isolate C on both sides, so I'm going to divide out my mass and my delta T on both sides of my equation. So mass cancels, delta T cancels. We should get, excuse me, our new formula should be Q over M delta T equals C. Now we can plug in and solve. So I'm going to have 204.75 joules divided by our mass of 15 grams. And our change in temperature, which when you calculate the change in temperature should be about 35. And remember, the change is the same in Celsius as it is in Kelvin. So I'm going to go ahead and make this Kelvin. When we do that, we should get roughly 0.39 joules per gram Kelvin as our specific heat capacity for copper. Just, I want to point out when we do this equation right here, if you're using a graphing calculator or any kind of calculator really, make sure you do your, so like one of those blue calculators, I would do my multiplication first and then go back and do my 204.75 divided by this answer. If you have a graphing calculator, I would do 204.75 divided by these two numbers in parentheses. So if you want to do double parentheses, your calculator will do PEMDAS for you. parentheses first, then division. If you do not do that correctly, you'll get a totally different answer. So please, please, please watch out for that. All right, let's look at the third one. 216 joules of energy is required to raise the temperature of aluminum from 15 to 35 degrees Celsius. Calculate the mass of aluminum. And they tell us the specific heat capacity of aluminum is 0.90 joules per gram Celsius. So once again, we're going to write down what terms we have and solve for what we need to find. So they tell us 216 joules. Excuse me. Our change in temperature. So they told us 15 to 35. So 15 would be my initial, 35 would be my final. And they want us to find the mass. They give us the specific heat. They told us it was 0.90 grams per, or joules per gram degrees Celsius. So this one I don't need to worry about converting to Kelvin since this is in Celsius and I have a Celsius in my units here. Once again, we'll write our formula, Q equals MC delta T. I'm going to rearrange my formula. So I'm going to isolate mass. So I'm going to divide out C delta T. C cancels, delta T cancels. I am left with Q over C delta T equals my mass. Now I can go ahead and plug and solve. 216 joules divided by my specific heat capacity of 0.90 joules per gram Celsius. And my change in temperature should be 20 degrees Celsius. And I can solve or calculate now my mass, which when I do that, I should get 12 grams. And that should be your final answer. Once again, don't worry about significant figures because they didn't ask for it. Number 4, the initial temperature of 150 grams of ethanol was 22 degrees Celsius. What will the final temperature of ethanol be if 3,240 joules was needed to raise the temperature of the ethanol? And they give us a specific heat capacity of ethanol, 2.44 joules per gram degrees Celsius. All right. Once again, we're going to plug in our values and see what we are given. All right, so we are told that the initial temperature of 150 grams. So we are told 150 grams, and in this case, we're given an initial temp of 22 degrees Celsius. All right, and they want us to figure out the final temperature. And they tell us our Q value is 3,240 joules, and they give us a specific heat. It's 2.44 joules per gram degrees Celsius. All right, now we're gonna have to solve for a final temperature. So first things first, we are going to write our formula. Q equals MC delta T. So whenever I have a problem like this where I'm solving for either the final or the initial temperature, I break it up into two separate equations. We'll solve for delta T first, then we'll find the initial or final, whichever one they're asking for. So let's first solve for delta T, our change in temperature. So once again, I want to rearrange my formula. For those of you who don't like doing that, just go ahead and solve, but I'm going to rearrange. So I need to isolate my delta T. So I'm going to divide out my MC. So I should get my new formula of Q over MC equals delta T. Now I'm going to plug and solve for my change in temperature. 3,240 joules divided by 150 grams times our specific heat of 2.4 joules per gram degrees Celsius. And this will give us our change in temperature. So remember, they're asking for a final temperature. This just gives us the change, okay? So now when I do this, I should be able to calculate a change in temperature of roughly about 8.85, which would be in degrees Celsius, okay? All right, so this just gives us the change in temperature. So remember, we need to find a final temperature. So our formula for change in temperature is change equals final minus initial. So now that we found the change and we were given the initial, we can plug and find final. So when we do this, our change in temperature is at 8.85 degrees Celsius equals final, which we don't know yet, that's what we have to solve for, minus our initial, our 22 degrees Celsius. Okay. So now I want to isolate final by itself so we can find out what it is. So in order to do that, you do the opposite operation. So we're subtracting, so we're going to add 22 to both sides so we can cancel out. And then when you do 8.85 plus 22, you should get about 30.85 degrees Celsius, which is equal to our final temp. Okay. So I broke it up into two separate equations. So I solve for delta T first, then plug into our delta T formula. So some of you like to, in the original formula, do Q equals MC final minus initial instead of the delta, and then solve with the one equation. I find that to be a little bit more confusing, so I separate it. We find delta T first, then we plug into the delta T formula. Okay, so you will see a question like that on your quiz, so please practice that. All right, let's look at number 5 now. The temperature of a piece of metal X with a mass of 95.4 grams increases from 25 degrees Celsius to 48 degrees Celsius as the metal absorbs 849 joules of heat. What is the specific heat of metal X? Once again, we're going to write down our terms. When we do this, we want to read through the problem and write down what we're given. So we were told that we have a Q value of 849 joules, a mass of 95.4 grams. They want us to find the specific heat, so that's our question mark, and our change in temperature from 25 to 48. So 25 is our initial, 48 is our final, so 48.0 minus 25.0 degrees Celsius. All right, so now that we identified our variables, we're going to plug into our formula. So we write our formula. Q equals MC delta T. So I'm going to rearrange the formula once again so it's a little bit easier. So we want to isolate the C, so we're going to divide out M and delta T. M's cancel, delta T's cancel. We're left with Q over M delta T equals C. Now we can plug in. 849 joules divided by our 95.4 grams and our change in T. So when you calculate the change in temperature, you should get about 23.0 degrees Celsius. Okay. All right. And this will give us our C value. So now when you plug this in, you're going to get about C equals 0.386 etc. So for this one, since we have a really long number here, I would round it off based on our significant figures, since I don't want this really long number. So my least number of significant figures would be 3. So I'm going to have equals 0.387. And again, our units for this are going to be joules per grams. And the standard unit is Kelvin, so I'm going to put Kelvin even though we use Celsius in our problem. Because remember, the change in temperature is the same for Celsius as it is for Kelvin. All right. Next, we're going to go on to number 6. Number 6, a piece of stainless steel with a mass of 1.5 grams absorbs 141 joules of heat when its temperature increases by 178 degrees Celsius. What is the specific heat of the stainless steel? Once again, we're going to write down our variables and figure out what we're given and what we need to find. They tell us a mass of 1.5, and again, that's in grams. They tell us a Q value of 141 joules. Temperature increases by. When it says increases by, decreases by, that's the change. So it's 178 degrees Celsius change. And they want us to find C. All right, once again, write our formula. Q equals MC delta T. And we're going to rearrange since we need to find C. So when I do this, I'm going to isolate the C. So once again, very similar to the last question when we do this. So I should get Q equals, or Q over, sorry, M delta T equals RC. Now we can plug in 141 joules over 1.55 grams. And we're going to multiply that by 178. So remember, the change in temperature is the same as in Celsius as it is in Kelvin. So I'm going to put it in Kelvin since our standard units for specific heat are in Kelvin. Now we can solve. When you do this, you should get about 0.511057 tons of numbers at the end. Long number, we're going to round based on sig figs just to make it shorter for us. So when you round it, our least number of sig figs is 3. So we want this number to also have 3, so you should have 0.511 joules per gram Kelvin. And this should be our final answer. Okay. Again, pay attention when plugging this into a calculator. These two terms have to be multiplied first before division occurs. So PEMDAS, parentheses first. So do double parentheses if you have to, but make sure that gets multiplied before the division occurs. All right, and our last one, number 7. When 435 joules of heat is added to 3.5 grams of olive oil at 21 degrees Celsius, the temperature increases to 85 degrees Celsius. What is the specific heat of olive oil? So once again, another question having us find C. So when we do this, we are going to plug in our variables we're given. So we're told we have 435 joules for Q, 3.4 grams for our mass. We're finding specific heat and our temperature increases from 21 to 85. So we're gonna have 85 minus 21. That's in Celsius. All right, once again, write our formula. Q equals MC delta T. I want to isolate my M to rearrange my formula. You don't have to, I find this easier. Q over M delta T equals C. Now I can plug in. 435 joules over your 3.4 grams times, when you do 85 minus 21, you should get 64. Once again, the change in temperature is the same in Celsius as it is for Kelvin, okay? So that's why I just did that. If I were to convert 85 to Kelvin and 21 to Kelvin, I would have the same change in temperature. All right, equals, when I do this, again, you're gonna get a really long number. We'll round it for significant figure purposes. So our least number of significant figures based on our numbers we are given is 2. So I would round this off. I should get about 2.0 joules per gram Kelvin. Okay? So those are the questions from page 38. So this answer key has been scanned and uploaded onto my website, and this video will also be on my website, and I'll let you know in the remind. So please make sure you study. If you have any questions, feel free to shoot me a remind. All right, good luck studying.